A warm Edinburgh, Scottish welcome to Emily Grossman. Thank you very much.
Hello. Thank you very much for that lovely introduction. It's nice to be here. It's a real honour to be given the opportunity to speak to you all and to come to Scotland. So thank you for your welcome. I wanted to talk to you about a sort of introduction to why we're here, to set the scene for where we are with maths and statistics in society, in the media, and why it's so important that we understand it, that we study it, and that we give it its due weight. So why is maths so important? I mean, I'm a maths teacher, so I can speak from a bit of my own experience, and my degree was natural sciences, so I actually studied maths as part of that as well. Maths is our only universal language. It's the only language that speaks to everybody. And it's too important for us to leave it just to the experts to understand. Now, I'm not just talking people who study it, but I'm talking the general public. Now, why do we need to know about maths? Well, it's important in everyday life. A lot of people don't realize that you're thinking of maths all the time, at least some people are. When we make decisions, when we analyze mortgage rates, when we look at mobile phone price plans, when we go shopping and we work out whether it's better to get a 20% discount or VAT off. Is that the same thing? No, it's actually not. When we're looking for a bargain holiday, to see if we're going to get ripped off by the latest scam, by the latest cheap deal on something or other, even if it's just splitting the bill in a restaurant. All of this is using basic maths. I realized I used it when I was trying to work out how to get my sofa through the door when I moved into my flat, and I was using Pythagoras in my head and thought, oh my God, I'm such a geek. Anyway, more about that later. But what about statistics? I mean, why do we need statistics? Well, again, whether we like it or not, we're analyzing data all the time. If we're in a scientific career where we're looking at policies, of course we need statistics to work out which policy is the best one. We need to understand it in the media. Even citizens who have nothing to do with maths or statistics need to understand how the media use statistics in order to be well informed. A quote from a recent report says that statistics are the bedrock of democracy. In a country where we care about what is happening, we must measure what matters, the key elements of national well-being. Without statistical understanding, citizens, voters, and consumers cannot play a full part. To call politicians, media, and business to account, we need the skills to know when spurious arguments are being advanced. Not only that, but knowing about maths is the best protection researchers have found against unemployment, against low income, and also against poor health. And it's central to the British economy. Even in careers, okay, some of us actually go into mathematical careers, but a lot of the careers that we don't think of requiring maths actually do. I mean, obviously things like architecture and engineering, we all know that, but things like journalism, things like media, they all require a basic mathematical ability, and in fact, sometimes more than that. And we're desperate for more scientists, for more engineers, for more technologists in those careers. By the year 2020, there's going to be spaces for 500,000 more graduates in those scientific and mathematical careers, and that's only to replace those retiring. That doesn't even incorporate new openings in mathematical careers. And believe it or not, researchers have found that if you're better at maths, and you get a better job, and you're more likely to earn more money. In fact, graduates with a maths A-level have been shown to earn, on average, 10% more than others. Okay, so that's why we need maths. So what's the current situation in this country regarding maths? Well, it's not great. In the UK, the maths ability of the average adult has been shown to be the equivalent to that of a primary school student. So that's nearly half of the UK's adults at primary school level. And employers are lamenting a lack of basic numeracy in their graduates. A survey was done where the UK was pitted against 65 other countries in terms of the mathematical numeracy of our 16-year-olds, our GCSE level students. And we came 26th out of 65. And we were 3 years behind the 16-year-olds in East Asia. So in terms of our mathematical ability at age 16. So that's pretty low down and it's pretty poor. So post-GCSE, what happens then? Well, another survey showed that actually only not even 20% of UK students go on to study any maths at all beyond the age of 16, beyond GCSE level. Of the 24 countries surveyed, we were in the bottom 3. England, Wales, Northern Ireland, bottom 3. Scotland was one above, but still not even 50% studying maths beyond GCSE. It's pretty poor. Only 11 to 15% actually study maths A-level. And we're the only country in which maths isn't compulsory for anyone, not even in vocational training, above the age of 16. So children are leaving school with poor numerical skills, little confidence in their own abilities to do maths, and little appreciation of why maths could even be relevant in society, let alone whether or not they want to use it in their jobs. The British Academy issued a statement a couple of years ago saying that they are deeply concerned at a lack of basic quantitative skills. They call it a virtual epidemic of statistical illiteracy, affecting business, schools, universities, with a serious consequence for the future of the UK's status as a world leader in research and higher education, for the employability of our graduates, and for the competitiveness of the UK's economy. So that's where we are. So why is it like this? Why are we in such dire straits when it comes to maths? Well, the first, and I think probably the most important reason, is that it's become socially acceptable to be rubbish at maths. Okay, I say become, it's always been like that. It's always been pretty cool to say, oh, I'm rubbish at maths, I can't do maths, you split the bill, I can't work out how to divide our bill by 10. It's been pretty cool, it's been a badge of honor to say, I can't add up. The country likes that. No one would say, oh, I can't read, I don't like writing, but it's become cool. Not only that, if you are good at maths and you do like it, you're seen as a geek. I get that a lot. I'm like, okay, I don't mind, but it's not socially acceptable to be a geek either. It's seen as the preserve for those who are clever, and also, and I think quite damagingly, it's seen as something that you're either good at or you're not. And if you're not, that's it. So it's a real confidence thing. And I think what it all comes down to is fear, a basic fear for numbers. And when I looked into this, I wasn't aware of this as a maths teacher, but apparently 1 in 4 of all people suffer from what's called maths anxiety. Now you might say, oh, what, you're not very good at maths, but it's actually a diagnosed thing where people have this irrational phobia of numbers. They have a blind panic when they look at a maths equation and freak out and don't know what to do. And this has actually been studied using the brains of school children, and scientists found that those 1 in 4 who have what's called maths anxiety, when they look at a maths problem, the same part of their brain that lights up for those with phobias when they see a snake or a spider gets activated. It's a real phobia response. And not only that, but the activation of the fear part of the brain actually then represses the problem-solving area of the brain, compounding the problem, so then that person feels more and more frightened and unable to do a maths problem. And recently this was quoted in the Telegraph as a crippling fear of numbers has left large swathes of the British population virtually incapable of seeing through what politicians, officials, and even salesmen tell them. So a lot of it comes down to fear. But what about those of us who aren't afraid? Not everyone's afraid of numbers. Well, another survey has shown that all of us, unless we're mathematicians, our brains are just not very good at dealing with large numbers. And it's not surprising when the media is always bandying around a million this, a billion this. We don't really have any real concept of what that is. So a lot of people were surveyed, and they were asked if they knew the difference, roughly, between 1 million seconds and 1 billion seconds. And a lot of people were very surprised to find out that 1 million seconds is just over 11 days. 1 billion seconds is actually just over 31 years. No one in the general public, well, not no one, but very few people were really aware of that huge discrepancy. Similarly, when the government quotes that they spend £133 billion bailing out the banks, and we equate this to, it comes down to about £2,000 per person. That's quite a lot. But when there's a government scandal and they're spending £1 million on something, and it's got huge coverage in the press and in the media and everyone's up in arms, if you do the maths, it actually only equates to about 10 pence per person. Really not worth us all having this big fuss about it. Why do we? Because we don't get the difference. Conceptually, our brains aren't hardwired to do that. And we're not hardwired either to understand basic statistics. We don't have any natural intuition about it. Our intuition is based on what goes on in our immediate surroundings, not what goes on at a wider level. So again, a survey was carried out. People were asked to estimate what proportion of the UK are immigrants. They came up with 24%, 24 in every 100. It's actually only 13%. They were asked how many teenagers got pregnant, how many teenage pregnancies there were, and they said 1 in 6. It's actually 1 in 33, far fewer. And similarly, they were asked about unemployment for those at employment age level, and they again came up with 24%. It's actually only 7%. This is a national survey. So you can see that people instinctively just don't have a real handle on what statistics is, and that's a real problem because people use their guts, their gut instinct, to analyse statistics in the media unless they've been trained in it, and it's their gut instincts which then lead them to vote, which is what we're going to come on and talk about. The other reason that I think that there's this issue with maths in our society at the moment is, controversially, the way it's taught. Now, I'm a maths teacher, and I know how difficult it is to teach maths, but it starts at a real primary school level. They say that if you haven't got a basic understanding of maths by the age of 11, you're basically stuffed. It's really hard to then claw your way back. And most primary school teachers don't have above GCSE level maths. That's the problem. So they don't necessarily understand it in a way or are passionate enough about it to teach it in a way that's inspiring, that uses practical examples, that makes it relevant to life, that talks about how it's relevant to different careers. So those school children are coming out without a basic understanding of maths, which is compounded by the fact that teachers have all this pressure from the government to get their kids through exams. So they teach them tricks, they teach them like little sneaky techniques to pass exams with maths, and they don't give them a basic grounding or foundation in order to go then out into a further understanding of maths. And those kids also, we're in a society where children are afraid to make mistakes. Now, in a lot of our schooling, if you make a mistake, the children come away thinking, oh, I'm just not very good at maths, compounded with what we already know about maths in society, apparently. If you're not good at maths, you're never going to be good at maths, then that's it. But actually, it's been shown that by making mistakes is the way that the brain most develops and grows. We only make new synapses in our brain, biologically, when we make mistakes. If we get something right, the brain doesn't grow. So if we're not encouraging children to make mistakes in maths and then still believe that they're able to then become a good mathematician and to get better, then they're not going to go anywhere. And this problem is then compounded through school, through A-level, into degrees, especially in the social sciences. Many of the degrees don't offer much training in quantitative skills, and then on into postdocs and PhDs and even research staff, there's a real lack in quantitative skills in those areas. And we are the only country where there is no compulsory maths, as I said earlier, beyond the age of 16. So I think that's a real eye-opener for why this is happening. So the question is, what do we do about it, or what is being done about it? Actually, before I say that, I just want to talk for a moment about the role of women in all this, because obviously that's something that's quite close to my heart. And having been very lucky, I went to an all-girls school. I didn't encounter any of this, oh, maths is for boys thing. Didn't even occur to me. I then went to Cambridge to do physics. Yes, I'm a biologist. What happened? I went to Cambridge to do physics, and I was surrounded pretty much 90% by men. And I was very confused, and I was very intimidated, and I was very put off. And in my maths and my physics lectures, it was all guys. It was guys doing the lecturing and running the courses and running the departments, and I lost my confidence. And I actually ended up changing to biology because I didn't think I was as good as the boys. When it came to the exams, I beat them. Go figure, how did that happen? I came out in tears, they came out laughing, I did better. That's something about the psychology of being female. And the way that it is in society, well, it's no surprise really. Back in the Renaissance time, the common perception of women was that their brains were too soft for rigorous theory, that their skulls were too small to house a powerful brain, and, get this, that exercising their brain would shrink their ovaries. So we've actually done remarkably well to get where we are from there. But still, nearly twice as many boys go on to study maths above GCSE level as girls. Only 8% of girls do maths A-level. Funnily enough, two-thirds of the girls who do really well at GCSE, get A stars, less than two-thirds of them then go on to take it at A-level. So there's an issue with actually ongoing confidence of taking it further, pursuing it to A-level standard and then on into degree. And in fact, one of the surveys, the one that surveyed 65 countries with maths ability, actually said that the UK was the lowest in terms of gender discrepancy. And what it means by that is about the difference between boys and girls thinking that they're good enough to do maths of those surveyed. And it was the biggest difference in numbers of the boys who thought they were good enough and the girls who did. There was the biggest gap in the UK out of all 65 countries. So why is that? It's still seen as not being for girls. It's still seen as being a boys' subject. There's a lack of role models in the media and in society, which there's great women out there, people like Rachel Riley, who are coming up and changing that. But it's also the faults of the mothers. There's a lot of mums who inadvertently let their daughters know that it's okay to not be good at maths. They say, oh, don't worry, I can't do maths either. And the problem is that in an environment where girls aren't expected to do as well, they don't do as well. Again, a survey showed that when women take a test, if they identify with being female, so they write their name on the top of the paper, they don't do as well as if it's just a random name at the top of the paper, and they do it to as well of their abilities. So when they're identifying themselves as a woman in a society where women are expected to not be as good, historically, then they're actually not being as good. Okay, so back to what we're going to do about it, or what we are doing about it. It's not all bad news. Maths is now the most popular A-level. It's just overtaken English. It's gone up by 15%, over 15% in the last 4 years. And actually, there's 2,000 more girls studying maths now than there were in 2010. So that's a big up. So it's on the mend. The government has just rolled out a new maths curriculum, which is extending the syllabus for a lot more problem solving to include financial maths. There's now a financial maths course that you can do above GCSE level instead of doing maths A-level to incorporate maths for those who may not want to study it further at A-level but still want a basic understanding. A lot of schools have pledged to up their teaching hours of maths by an hour a week. That's a huge amount. To introduce new teachers and to add professional development for the teachers that they have to give them professional development training in the schools. So this is all great stuff. 32 schools have been designated maths hubs by the government, which means that they are designated schools to spread good teaching and to investigate good teaching practice. 70 teachers across the country, maths teachers, have been sent to Eastern Asia, which is where the best results for maths are coming out, to investigate what it is that they're doing over there that's so good. There's more role models on the media. This is on the up as well. There's the Q-Step initiative, which is investigating pledging money to help add quantitative training and skills at degree level. And AQMeN itself is actually doing training as well for PhD and postgraduates, postdocs, researchers and staff to increase the level of quantitative skills within scientific degrees and beyond. And on the women front, we're not doing too badly because the first female to win the Fields Medal, which is the maths equivalent of the Nobel Prize, was this year an Iranian woman who won it for her work on complex geometry. So we're all right, we're getting there, but it's still a problem. And one of the biggest problems that I've encountered in my work, not as a teacher, but actually as a broadcaster, is how statistics can be distorted in the media, how those issues come in, and how they then get spread, whether it's unintentional or whether it's willful abuse of statistics. It's out there and it's happening, and we need statistical awareness to be able to spot when that happens. And I've come across to this, and I'm just going to briefly tell you about 3 different scenarios that have happened to me where I came a bit unstuck because of what was going on statistically that confused me from the media. So the first one was very much how statistics can actually, even the experts can get it wrong. So when I was doing Duck, Quacks, Don't Echo last year, I was given a question: is it true that left-handed people, on average, die 9 years younger than right-handed people? I'm left-handed, a little bit scary. I looked into it. On a TV program, it's very fast and furious. You have very little time to do research, a couple of hours at best. So I did a bit of research, came out with the document, and was just like, yeah, it's true. A study was done in the late 80s, early 90s, and yes, it was shown that they died on average 9 years younger. I was then pulled up on this and told, actually, this study has been disproven. But to my slight relief, I learned that actually it's a mistake that's been made quite a lot, and it's a sort of inherent flaw in that type of statistics. Now, what happened was that the study was based on death cohorts, which means that they studied 2,000 Californians who had died, and they asked their relatives if they were left or right-handed. And they found, on average, the right-handed people died older. What that is actually saying in the real world is that there is a better statistical proportional representation of left-handed people amongst younger people who died. It's kind of like saying, if you analysed all the dead people now, people who died yesterday, and you said, what age were the people who died who used Facebook? And you said, well, actually, most of the people who used Facebook died at the age of sort of between 20 and 30, but most of the people who didn't like Facebook died at the age of 90. So you would say, okay, well, in which case you might conclude that using Facebook makes you die younger. No, the population of people using Facebook are just younger. Similarly, back in the late 80s, the population of people who were left-handed or identified themselves as left-handed, crucially, were younger because it was socially unacceptable to be left-handed. It was stigmatized. They made a mess in industry because all the machines were for right-handed people. They made a mess in the classrooms because the desks were for right-handed people. So they didn't admit to being left-handed, whereas the younger people did. So it was a misrepresentative proportion. And that's where that statistic came from. And it was quoted in Nature. It was quoted in the New England Journal of Medicine. So that's the experts really genuinely making mistakes here, and it can happen to the best of us. Second quick example is I was researching a fact on, I'm the expert on the Alan Titchmarsh show on daytime TV, and I was researching a fact. Someone asked, is it true that cats don't like being stroked? So again, had very little time to do this, had a quick look, and saw all these headlines saying, cats don't like being stroked. Don't stroke your cats. Yes, they were tabloids, but anyway. Do not stroke your cats. It will make them stressed. When I dug a bit deeper, I saw that that was a case where the actual research had been slightly misreported and misinterpreted by the media. What the research showed was that if a cat didn't like being stroked, and you stroked it, it would tolerate it and it would get more stressed. Not that if you stroked any cat, it would get more stressed. But all the headlines basically reported, I guess, the more sensationalist version of the fact. And I actually went on daytime TV basically saying, don't stroke your cat. How embarrassing. And my final example is how sometimes the media can willfully distort or abuse statistics. Now, I was invited on this morning to talk about a woman, a black woman, who had a white baby. And it was bandied about the headlines, again, it was the tabloid headlines, that this was a 1,000,000-to-1 baby. There was a 1,000,000-to-1 chance that this would have happened. Now, I'm a geneticist, or at least I was originally, and I know a bit about genetics, and I didn't know that much about skin color, so I looked into it, I spoke to a lot of geneticists, and I could not come up with an explanation that was that simplistic. How can you possibly know the chance of having a baby of a particular colored skin without doing profiling of the DNA with a sample size of 1, where you've got 1 child? And basically, somewhere along the line, had come up with this 1,000,000-to-1 statistic, which I figured out could be skin color is controlled by 20 genes. If the black mother had a white recessive allele at every single locus for those 20 genes, 0.5, so the chance of inheriting that allele, to the power 20 is 1 million, or a millionth. So I reckon that's where they got it from. I don't reckon that's necessarily how it came about, but I tried to say that on daytime TV and they were not having any of it. All they wanted was, it's a 1,000,000-to-1 chance, isn't it? Isn't it? Isn't it? They were not interested. So there are situations where we need to be able to know, as discerning members of the public, whether or not we're into maths and statistics or not, we need to be able to discern what's true and what's not true, and to be able to have some kind of feel for numbers and an understanding of numbers, particularly as we're going to hear in political campaigns, and understanding spin and understanding where numbers actually come from and what it means. And just to finish off, yes, we're in a good place. Yes, things are getting better. But just to show you what we're up against in terms of what the general members of the public think of statistics and think of data and think of stuff that we're talking about, I just wanted to show you this YouTube clip, which was a recent episode of BBC NewsHour.
working. I
think it's
you
got a
know
lot of
that a
flaws.
system that requires quantitative easing to hold it together, while energy companies are subsidised by our taxes, while renewable energies are ignored. I know you can't support that system, Evan. I know you're mates with CEOs and big business
Let me bring up
figures.
a graph. I've
I
got a
don't
graph
want to
here.
look at a graph,
No, look,
mate.
let's
I
pick
ain't
a
got
graph.
time for a bloody graph. Well, this is what I want to take this opportunity to talk to the people of this country
just
and
don't-
tell them to
look
get
at this
involved
graph.
in
This is
creative
quite
direct action.
interesting, 'cause
That's a lovely graph.
It goes back
well
to
done, mate.
1862.
This is the kind of stuff that people like you
No,
use
it's not.
to confuse people like us.
I'm not trying to
I've got a
confuse
graph,
you.
mate.
I'm not trying to confuse you.
You've not just come from the
Russell.
new era estate where Boris Johnson, who takes five
Russell,
times
do you
more
know-
meetings a
do you know-
year with bankers than he
Trying-
does ordinary people.
trying-
We've got a graph. Everything's tidy.
Trying to just take 5.
What he said was, this is the kind of thing that people like you use to confuse people like us. I don't want to see a bloody graph. That's what we're up against. Thank you.